What if you could somehow take a tiny piece of the sun, bring it to Earth, and actually eat it? At first, the idea sounds almost ridiculous. The sun is enormous, incredibly hot, and located about 150 million kilometers away from Earth. But let's ignore the impossible part for a moment and imagine that through some futuristic technology, a tiny amount of solar material could somehow be brought directly to you. What would happen if you put it in your mouth? The first thing we need to understand is that there isn't really such a thing as a normal solid piece of the sun. The sun is not made of rock like Earth. It is mostly plasma, an extremely hot state of matter in which atoms have been stripped of many of their electrons. The visible surface of the sun is around 5,500 degrees Celsius, and that's actually the relatively cool part. Deeper inside the sun, temperatures reach millions of degrees, so imagine a tiny amount of this incredibly hot plasma somehow appearing in front of you. The first problem wouldn't be digestion, it would be heat. Your body is mostly water, and water is extremely sensitive to temperature. Your cells, proteins, blood, and organs all depend on carefully controlled temperatures. Even relatively small changes can interfere with biological processes. Solar plasma is on an entirely different level. The moment an extremely hot plasma sample came into contact with the air around your mouth, it would begin transferring energy to its surroundings. The air would heat rapidly. Water molecules would absorb enormous amounts of energy. The plasma would also expand and interact with the surrounding matter. In other words, it wouldn't behave like a tiny piece of hot metal that you could simply swallow. It would be more like placing an extremely concentrated source of thermal energy directly inside a biological system. And then things get even more interesting. Your mouth contains moisture. Your saliva is mostly water. The tissues inside your mouth also contain huge amounts of water. When water receives enough energy, it changes from liquid into vapor. Now imagine that process happening extremely quickly around an incredibly hot source. Instead of slowly warming up, the surrounding water could rapidly turn into expanding vapor. That expansion would create intense pressure and transfer even more heat into nearby tissue. Your body simply isn't designed to deal with energy being deposited that quickly, and this is why the phrase eating the sun is actually misleading. You wouldn't really be eating it. You would be introducing an extremely energetic physical system into a biological environment that has evolved to operate within a very narrow temperature range. But let's assume somehow that a small amount of the material survived long enough to move deeper into your digestive system. Your stomach wouldn't save you. The stomach contains hydrochloric acid and powerful digestive enzymes. These chemicals are excellent at breaking down food, but digestion works through chemical reactions. It doesn't magically neutralize extreme temperatures. Stomach acid might destroy bacteria and help break down proteins, but it can't simply digest plasma that is thousands of degrees hot. Instead, the surrounding fluids would absorb the energy, water would heat, molecules would move faster, chemical bonds could begin breaking apart, and the energy would spread through the surrounding tissue. The exact result would depend on something extremely important: how much solar material we're talking about. A microscopic amount and a kilogram of material would produce completely different outcomes. This is where the physics becomes more interesting. The sun itself produces an almost unimaginable amount of energy every second through nuclear fusion. Deep inside its core, enormous pressure and temperature allow hydrogen nuclei to fuse together and form helium. During this process, a small amount of mass is converted into energy. The sun releases roughly 3.8 times 10 to the 26 joules of energy every second. That's an almost impossible number to imagine. But here's an important detail. A tiny piece of solar plasma would not contain the entire energy output of the sun. You're not carrying the sun's entire power source inside your body. It comes from the temperature and the rate at which energy can be transferred to your surroundings. Think about it this way: you don't need the entire ocean to drown. You only need enough water in the wrong place. Similarly, you don't need the energy output of the entire sun to cause catastrophic damage to biological tissue. You only need an extreme amount of energy concentrated in a very small area, and heat wouldn't be the only problem. The sun also produces enormous amounts of electromagnetic radiation. Solar radiation includes visible light, ultraviolet radiation, X-rays, and other forms of electromagnetic energy. Earth is protected from much of the most dangerous solar radiation by its atmosphere and magnetic field. But if solar material were placed directly next to your body, you wouldn't have that same protection. There could also be energetic charged particles associated with the solar plasma. These particles can interact with matter and, at sufficiently high energies, damage biological molecules. So, even if we somehow ignored the temperature problem, radiation would create another serious problem. But would your body literally explode? Probably not in the Hollywood sense. Real physics is much more complicated. The main effects would depend on the amount of material, its temperature, its density, and how quickly it could transfer energy. If enough water were heated extremely rapidly, it could become vapor and expand. That expansion could generate dangerous pressure. But a microscopic amount of plasma would behave very differently from a large quantity. This distinction is important because the phrase, "a piece of the sun," doesn't tell us how much matter we're actually dealing with. There's another fascinating problem. The sun's plasma doesn't naturally remain in the same state once removed from the sun. The sun's enormous gravity and pressure help maintain its extreme environment. Take a small amount away from that environment, and it begins interacting with its surroundings. It can expand, it can cool, it can transfer energy, and it can interact with magnetic fields and surrounding particles. So maintaining a stable piece of solar plasma on Earth would already be an enormous technological challenge. In fact, scientists on Earth already work with plasma in controlled environments, including fusion research. But creating and controlling extremely hot plasma requires sophisticated equipment, powerful magnetic fields, vacuum systems, and enormous amounts of engineering. Your stomach is definitely not one of those containment systems, and that's what makes this thought experiment so interesting. The sun looks peaceful from Earth. We see a bright circle in the sky. We feel its warmth on our skin. It gives plants energy, drives Earth's climate system, and provides the energy that supports almost every ecosystem on our planet. But that same sun is an enormous nuclear fusion environment. Its surface is thousands of degrees hot. Its interior reaches millions of degrees. It constantly releases radiation and charged particles into space. From 150 million kilometers away, Earth receives only a tiny fraction of that energy, and thankfully our atmosphere, magnetic field, and distance protect us from the extreme environment surrounding the sun. So what would happen if you actually ate a piece of the sun? You wouldn't simply get burned. The idea of eating it doesn't really work because the material wouldn't behave like ordinary food in the first place. An extremely hot sample of solar plasma would rapidly transfer energy to its surroundings, heat and potentially vaporize water, create expanding gases, expose nearby tissue to extreme temperatures, and potentially introduce energetic radiation and charged particles. The result would be completely incompatible with normal human biology, and the strangest part is that the sun wouldn't even need to notice. Compared with the enormous mass and energy of the sun, the tiny amount involved in our thought experiment would be practically nothing. If you enjoyed this video, subscribe for more mind-blowing what-if scenarios, and comment below, what should we explore next?